So we are going to see how we can be able to get equation of a straight line when we have been given 2 points of that line. Now let's consider this line, a line passing through these 2 points, point A, 3,1, and point B, 6,4. We have already worked out the gradient of this line, so it's an advantage to us. The first step is to calculate the gradient or the steepness of that particular line. All right. So, and we have learned in the first session that what you need to do is get the change in y and the change in x coordinates. Okay. So we first calculate the gradient, and I know you can be able to calculate the gradient of this line passing through point A and point B. What do? You just let point A to be your first point and point B to be your second point. Therefore, using the formula for calculating gradient, you will say change in y coordinates, which is y2. Where do we get y2? Point B is our second point, so y2 is 4. And then y1 is going to be at point A, which is 1. Okay. Then we continue. For x, change in x is going to be 6 minus 3. So calculate the gradient of this line first. So this is what you do. You say 4 minus 1 for the change in y, 6 minus 3 for the change in x, and you get that is 3 divided by 3. And when it's in that manner, our value for the gradient is 1. The value for gradient is 1. The second step in calculating or finding the equation of a straight line, after calculating the gradient of a line using those 2 points you had been given, now you need to take only one of the points. Let's say you can pick A as your point that will help you to calculate the gradient, not gradient, but equation. Okay, let's say you pick A, all right, and then in that case, the next point that you pick, you don't write its coordinate, but you just represent the coordinates in terms of x and y. So now you are going to algebra. You use the terms. You don't use the coordinates or the numbers that you had been given. Let's look at what I used. We rewrite the gradient now using our first point, which I have picked as B. One of the points I've just picked B. So I say instead of using 3, 1, and 6 and 4, I'm going to use 6 and 4, and then the other one to be x, y. So you just pick one of the coordinates, and the other coordinate becomes x, y. Are we together? Up to that point?
Yes.
All right, good. So the next thing you do is now you rearrange as if you are just calculating gradient in a straightforward manner, but instead of using the value, in this case we used 1 and 3, all with 4 and 6. Now we are going to use 4 for the point B. We are going to use the coordinates for point B, that is 4, and y. So the change in y is going to be 4 minus y. Okay, and then for the x, change in x is going to be 6. This 6 minus x. All right, because I've chosen this particular point and the other one to become xy. If you choose the other first question, you can say y minus 1 divided by x minus 3. That's how your calculation should look like. Then what happens after this? We already know what the gradient is. So this particular expression is supposed to be equated to what? Equated to 1, our gradient, which we already know. Now, after equating, you simply cross multiply, or you can simplify your equation. Look at that. I have just said 6 minus x is on the denominator of our first expression. Then I can multiply it with the 1 on the other side, and the equation becomes what? 4 minus y is equal to 6 minus x. Let me show you how this is going to happen. I use an arrow. This particular value here below is being multiplied by the numerator on the other on the other side of the equation. And then this numerator on the first part will be multiplied by, of course, there is a 1 here. Now we get 4 minus y being equal to 6 minus x. At that particular point, I know very well that you can be able to solve and be able to solve. And this is how you rearrange your equation, that the equation of a straight line should look as we have stated here. Y should be equal to mx minus or plus c. So what did I do in this first question? Is what happens when you multiply these particular points, this 1 by 6 minus x, you get 6 minus x, this value. Then when you also multiply by 4 minus y all over 1, in this case here we normally have a 1. So this gives us 4 minus y is equal to 6 minus x. Then to just remain with y on one side, this is what I did. I took y, because it's a negative on that side, I brought it to the right-hand side, giving me a positive y. And then this 6, bringing it to the other side. So I'm going to have 4 minus 6, because it's a plus, and we are shifting it on the equation side. This is going to give us what? Going to give us the 2, but negative. Okay? Going to give us a negative 2. And the x, because it's already minus, when it shifts to the other side, it becomes positive this side. So now our equation is in that particular form. I want you to take your time, you'll study through that, and you can be able to grasp what is happening there. So our equation for the line is y is equal to x minus 2. That is the equation for our line. I want to take us to GeoGebra and confirm that line, if it's actually having those points or coordinates for A and B, unless there is a question first. All right, that's good. So I need you to note that the equation of a straight line is given in the form y is mx plus c. Later on, I'll be able to explain to you the value of m actually is our gradient. That's why we were referring to it as m. So m, in this equation, at this particular point, there is a 1. At this point here, there is a 1 here. So 1x. Now, let's proceed. The next part. If you have been given only one part or 1 point and a gradient, how can you be able to get the equation of a straight line? Determine the equation for a line that is passing through this point, A, 3, 1, but the gradient is 1. So the first thing you do, as we did in the first particular question, you just let the second point to have coordinates x and y. Let the second point have coordinates x and y. So you pick the first point you've been given. Now the second point becomes x, y. Then what you do is you rewrite the equation for calculating gradient, and that will give you what? The change in y all over change in x. Okay? So therefore, we'll have our point B or point A becoming our first point. So we're going to take the coordinates that we've been given minus the coordinates for the other assumed point. So 1 minus y all over 3 minus the x. Okay? So we equate it. We already know the gradient is 1. So that expression or equation is for calculating gradient. Then what we do, simply cross multiply as we said before. So after cross multiplying, what you need to do is just to simplify. And you have the equation. Remember, write the equation in form of y is equal to mx plus or minus c. All right, power from our side, a disruption, but we are back. We can finish. Just share. Okay. Good. So we had done the first part. Let me just take it a little bit back. So we were simplifying. We were simplifying our equation after cross multiplication. We just need to now represent or rearrange. I will want you to really work on the rearranging, because once you are told to arrange your equation in a different format, you need to be able to do that. So in this form that we are learning today, the equation is just in the form y is equivalent to mx plus c. And you can see the value of m is standing for gradient. Our m at this particular point here, the m is the gradient here. That is 1. When we got gradient, it was 1, or we were given gradient is 1. So you can easily be able to know whether your equation is right or wrong once you get to see the value of m, what is coming before x. Then minus 2, that will be our intercept for the y-axis. I want to take this equation and plot a graph so that you see the graph's values on the other side. We'll take you to your algebra on the other side. Y is equals to x minus 2. So that is our equation. And the line, I hope you can be able to see it from the screen. This is our line. So looking at this line from the equation, this is a straight line. Now look at this value. In our equation, we are saying that y is equal to x minus c. And when you look at the line, you can be able to get that the intercept on the y-axis is actually the minus 2 in our equation. Okay? So when we get the slope of this line, we get the slope of this line. Let me just get it from here. It's here. I wasn't seeing it, so let's measure the slope. What you're telling. Slope. Then this is our line. So you can see m is equal to 1. So that is for our line. The straight line's slope is m is equal to 1. That's how we work out gradient and equation of a line. Gradient and equation of a line. I hope we are good up to that point. I take us back. Right. So let me take you to the last bit. I wouldn't want to give you so much than you can be able to digest. Go to the next one. Now we need to get the equation of a straight line. Once we've been given gradient and 1 point, we can be able to find that. I want us to try this. I've given you the second one, but you now need to know how you get there. The first one, I've given you the point and I've given you the gradient. So I want you to try and see if you can arrive at an equation for the first line passing through point F with coordinates 2, 3 and gradient 3. And then I want you to see if you can arrive at that equation for the second line, which is passing through point G and has coordinates 6, 0 and with gradient 2 all over 3. If you are done, let me know. Yeah, silent, or I can't hear your audio.
We are there.
Kuna mtu amepata ya kwanza ama bado?
Bado.
Umefikia wapi? Umepata the second point as xy.
Yeah.
Good. Then may equate to the gradient. You
Bado.
let the second point be xy. Then you rewrite the gradient. How do you rewrite the gradient? Change in y by change in x. So you write that way. Normally, I pick the values, the coordinates have been given as my second point. So that's why I say y2 is 3 and y1 is just the y which I've chosen as another point xy. So ukiwa na hiyo, then unasema let it be equal to the gradient 3. Then cross multiply. You see that you are multiplying 3 by the denominator. 3 is a numerator on the other side. So ukimultiply hivyo, what do you get? You open that bracket and simplify. 3 by 2 is 6. And then 3 by minus x is minus 3x. So after that, you simplify and you get the equation. So the equation that I wanted you to get, if you have gotten y is equal to 3x minus 3, that's very good. Write the gradient. How do you rewrite the gradient? Change in y by change in x. So you write that way. Normally, I pick the values, the coordinates have been given as my second point. So that's why I say y2 is 3 and y1 is just the y which I've chosen as another point xy. So ukiwa na hiyo, then unasema let it be equal to the gradient 3. Then cross multiply. You see that you are multiplying 3 by the denominator. 3 is a numerator on the other side. So ukimultiply hivyo, what do you get? You open that bracket and simplify. 3 by 2 is 6. And then 3 by minus x is minus 3x. So after that, you simplify and you get the equation. So the equation that I wanted you to get, if you have gotten y is equal to 3x minus 3, that's very good. That means we take a break. Thank you for coming. And see you tomorrow. Bye-bye.
Okay.
Tunaweza tuma pesa. Tulibado tunatuma wote, si ndio? Bado wameshalipa. Unaweza kawa direct.
All right, you can leave.